All right, so 8.2, we're going to continue with our series and sequences, but we're going to look at more specific types of series and sequences. So these are arithmetic sequences. So an arithmetic sequence is when you add the same number to each term. So if we started out with a number, you add 2, add 2, add 2, add 2 to get to the same. That 2 is called the common difference. So that same number that you add each time, we call it the common difference. So if you're not adding the same number each time to get to the next term, it's not an arithmetic sequence. So in example 1, it says, identify the arithmetic sequence, tell whether each sequence is arithmetic. So let's see. What are we adding to get from -9 to -2? We're adding 7. What are we adding to get from -2 to 5? 7. Are we adding 7 again here from 5 to 12? And from 12 to 19? 7. So is this an arithmetic sequence? Yes. And what's our common difference? 7. So it doesn't ask us to find the common difference, but we're going to have to do it in the next few examples, so might as well just identify it here. All right, let's look at B. So here our numbers are getting smaller, so what are we subtracting to get from one number to the next? -8. What about from 15 to 9? What do we subtract? -6. And from 9 to 5? -4. And from 5 to 3? -2. So is this an arithmetic sequence? Nope. It's not adding or subtracting the same number. So not arithmetic. Any questions on these? All right, we have 3 more examples just like it. So our numbers are getting bigger. What are we adding to get from 2 to 5? 3. Are we adding 3 each time? Yep. So is this arithmetic? Yep. So yes, and what's our common difference? 3. Number 2. Our numbers are getting smaller. What are we subtracting here? 15 minus 4 would be, so 6 minus 6. Are we subtracting 6 to get from 9 to 3? Yep. What about from 3 to -3? And -3 to -9? Yep. So is this arithmetic? Yes. And what's our common difference? -6. Awesome. And then last one, number 3. What are we subtracting to get from 8 to 4? -4. And from 4 to 2? 2. These are different, so we could just stop right here. We already know it is not arithmetic. All right, next. So we have a certain formula that helps us come up with a rule when we have an arithmetic sequence. So this equation, this formula, only applies to arithmetic sequences. So the nth term of an arithmetic sequence with the first term a sub 1 and common difference d is given by this. So we can find any nth term, so we can find a sub 100 with this formula. A sub 1 is our first term. N is the number of terms, or the number of term we're looking for. So the number of term. And D is the common difference. And then it gives us an example here. But let's look at example 2a. So write the rule for the nth term of each sequence, then find a sub 15. So first thing we want to do is find our common difference. So what are we adding to get from 3 to 8? 5. we're adding 5 to get from 8 to 13 and adding 5 here. So what's D equal to? 5. And what's A sub 1? What's our first term? 3. Our first term is here. So we just want to plug that into our formula. We have A sub n is equal to, plug in A sub 1, which is 3, plus n minus 1 times D, which is 5. Now to simplify this formula a little bit, what do you think we need to do?
Find the number of terms, find n.
Not find n. We want to kind of condense this formula because we have a lot of numbers in here. We want to make it a little bit smaller, a little bit prettier. What can I do?
Distribute.
Distribute the 5. So I have 3 plus 5n minus 5. And then do I have any like terms that I can combine? 3 and negative 5. So this would be 5n minus 2. So this is my rule for the sequence. Now it asks me to find A sub 15. So I'm going to find A sub 15. So what am I going to plug in for n? 15. So 5 times 15 minus 2. What's 5 times 15? 75. And 75 minus 2 would be 73. So our 15th term of this sequence is 73. Which we could, because this is term number 1, term 2, term 3, term 4, we could just keep adding 5, adding 5, adding 5, adding 5 until we get to our 15th term, but that would take way too long. So it just helps to come up with your rule, your little equation here for your series, for your sequence, and then find that term that we're looking for. Any questions here? All right, let's look at B. So our numbers are getting smaller here. What are we subtracting each time? So minus 8, minus 8, minus 8. So what's D? Negative 8. And then what's our first term? 55. So let's plug that into our formula. We have A sub n is equal to A sub 1, which is 55, plus n minus 1 times D, which is negative 8. How can I simplify this? Distribute the negative 8. So I have 55 plus, or I guess this would be minus, 8n plus 8. And then can I simplify it anymore? So I have negative 8n, what's 55 plus 8? 63. So I have negative 8. What am I going to plug in for n? 15 plus 63. So negative 8 times 15 is negative 120 plus 63. So A sub 15 is what? Awesome, negative 57. All right, so let's look at the next example, number 4. Write a rule for the nth term of the sequence, then find A sub 15. So we need to find our common difference first. So what are we adding to get from one term to the next? Adding 4, and adding 4. So what's our D?
4.
D is 4. And what is our a sub 1? 7. So we have a sub n is equal to a sub 1, which is 7, plus n minus 1 times d, which is 4. How can we simplify? Distribute the 4. So 7 plus 4n minus 4. Then we can combine some like terms. We have 4n plus 3. So this is our rule. Now we want to find a sub 15. So what are we going to plug in for n? 15. So 4 times 15 is 60. And 60 plus 3? 63. So next we're going to find the sum of a finite arithmetic series. So we've been finding the sum before. That's when we have this little summation thing. But we have been plugging in each number from whatever it gives us at the bottom. So like I is equal to 1 to I is equal to some number up top. So like 5. We've just been plugging in every number between. But now we're going to be given like big numbers up here like 20. And we don't want to have to plug in 20 numbers and add them all together. So we have a formula for that. So this is our formula. The sum of n terms is equal to n. So that is our number of terms. So number of terms. A sub 1 is our first term. A sub n is our last term. So we always have to plug in the first number here, and we're going to have to plug in the last number here to find what a sub n is. And then we just put everything into our formula, and that'll give us the sum. So example 5, we have to find the sum. So our formula is the sum of n terms is equal to n times a sub 1 plus a sub n over 2. So how many terms do we have here in this series? We have from 1 to 20. So how many terms here? What's our n going to be equal to? How many?
20.
Perfect, 20. There's 20 numbers from 1 to 20. Now we want to find our a sub 1. So we're going to plug in 1. So we have 3 times 1 plus 7. What's 3 times 1 plus 7? 10. And then we want to find our a sub n, which our n is 20, so we're going to find our a sub 20. We always plug in the first number and the last number. So we're plugging in 20. So 3 times 20 plus 7. What's 3 times 20? 60, and 60 plus 7? 67. And now we can plug everything into our formula. So we have the sum of these 20 numbers is equal to 20 times a sub 1 is 10 plus 67 over 2. So our sum. What should we do first according to PEMDAS? The parentheses, but what in the parentheses should we do first? the addition up top. So 10 plus 67 would be 77 divided by 2. What's 77 divided by 2? 38.5, and 38.5 times 20? What was that? 770. Oops. 770. So that's our sum. So if we were to plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 20 into this little equation here and added all those numbers up together, we would get 770. But this is a lot quicker of a way to do that than to plug all those numbers in. But this formula only works when you have an arithmetic sequence. All right, we got a couple more. So let's look at the next one. I'll write our formula again up top. We have n times a sub 1 plus a sub n over 2. So for number 7, what's our n? How many numbers are we dealing with here? 10. What's our first term?
1.
So 1 is the first number we're plugging in. When we plug in 1, that gives you your first term. So if we plug in 1, that would be 9 times 1. So a sub 1 is 9. And then we want to find our 10th term. So when we plug in 10, what do we get?
90.
90. So you always plug in your first one and your last one. And then we just plug everything into our formula. We have 10 times a sub 1 is 9 plus a sub 10 is 90 over 2. Got to follow our order of operations. 9 plus 90 is 99. So 99 divided by 2 would be 50.5. No, 49.5. Yeah, 49.5. And 49.5 times 10? 495. So our sum of our 20 numbers, or 10 numbers here, sorry, so S sub 10 is equal to 495. All right, let's take a look at 8. What's our n? 12. 12 numbers total from 1 to 12. What is our a sub 1? 7k plus 2. So 7 times 1 plus 2. Because we're plugging in 1. So we always plug in the first, then we plug in the last. So 7 times 1 plus 2 would be 9. And then we have to find our a sub 12.
86.
So 7 times 12 plus 2, 86. Are you sure about that? I believe you.
Yeah.
Yeah. All right, and then we just plug everything in. So we have n, which is 12, times our first plus our last, divided by 2. So 12 times 9 plus 86 would be 95, divided by 2. So the sum of our 12 numbers is 570. All right, last problem, then we're done for the day. Number 9. What's our n? 20. What's our a sub 1? we plug in 1, so negative 4 plus 6 would give us 2. And then what's our a sub 20?
-74.
Awesome, negative 74. So we plug everything in, we have n, so 20 times a sub 1 plus a sub 2. That's here, since it's negative, we would just do minus. Put her all together. So we have 2 minus 74 is negative 72 divided by 2 times 20. What do we get?
I have a question.
Yes.
Wouldn't it be 2 plus 74? Because like the minus is already there, and then it's like negative 74.
Because our formula is plus,
Oh.
so it would be like plus a negative 74. So it would technically just be a minus.
Okay.
Good question. What do we get?
$720.
Positive or negative?
Negative.
Negative 720. Good job.